Hello everybody and welcome to EduCounts. In this lesson we're going to discover together the key features of the quadratic parent function. So let's get started and see what do we have in this lesson. So what is the parent function or the quadratic function? The quadratic function is a function that has a quadratic expression. That means we have x squared is the degree of this expression. And this function could be written in this form: ax squared plus bx plus c, where a does not equal to 0. Because if a was 0, so everything here is going to be, or the first term, which is ax squared, would be 0. So that makes the function a linear function instead of the quadratic one. So we're going to talk specifically in this video about the parent function. And the parent function is written in this form: f of x is equal ax squared. Okay, so this is the there's a parent form where b and c are equal zeros. So since we don't have here any more terms except the first term, which is ax squared. One more thing we need to understand, which is the name of the graph, or this function takes a graph as a U shape, and this U shape has a special name, which is the parabola. We have two possibilities for the graph of the parent function or the parent quadratic function. The first possibility when is something is higher than 0 or a positive number, and the second possibility when a is less than 0 or a negative number. Okay, so in this slide, you can notice that the parent quadratic function written in this form, which is f of x is equal x squared, where a is equal 1. So, and the graph takes here a U shape, and you can notice that this graph has two sides. One of them is red, another one is blue, and it's written here as decreasing and increasing. We have a vertex, we have axis of symmetry. So all of these key features, we're going to discover them step by step together. So here it is an example when a is something is higher than 0, which is a positive number. So let's say that we have this function, which is a parent function. As you can see here, we have the graph, and this graph here, it has two sections. One of them is red section and another one is a green one. The key features that we need to understand them or realize, which is the domain. What is the domain of this function? The range and the line of symmetry, the vertex, increasing interval and decreasing interval. So let's get started. The first idea, which is the domain. We're going to use the idea of moving on the x-axis here. If someone moving on the x-axis and he is moving from or walking from the left-hand side to the right-hand side, so in this direction, so we can simply notice that this person can see the graph everywhere above him. So which means that we don't have any gaps in this graph. So all of the numbers that are available on the x-axis could be used in our domain. So in this case, we're going to use that these are the all real numbers, which is r. So the domain of this function is all real numbers. What about the range? The range, we're going to use the idea of moving on the y-axis. If the same person was moving on the y-axis from the bottom to the top of the graph, so for the part or the two sections below the x-axis, this guy cannot see any graph to the right or to the left. So the graph starts from this point, which is 0 and 0, and goes up. So the person can see the graph here to the right and to the left, like this. And in this case, we're going to say that the range of this function starts from y is equal or higher than 0. Third property that we have here about this function is the line of symmetry. This graph is a symmetric one, since we can see right now we have two sections, one to the right, so this section is to the right here, and we have another section to the left, which is this part, and the line or the axis of the y-axis is dividing the graph into two identical halves. So you can find here any point, it has another point to the opposite side. Every single point has another point, okay, like this. So we can see that this graph is symmetric, and the line of symmetry here is the y-axis, or x is equal to 0, since x is equal to 0 is the same as the y-axis. Okay, so this is the line of symmetry. The vertex of this graph, as you can see here, this graph goes down, down, down until we reach this point. And this point, it has another name. Some people called it as the turning point, since the function it changes its behavior here. So this point, which is the vertex, is the origin point, which is 0 and 0. and this is the vertex. And we can notice that this function goes down here, down, 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 until we reach this point, and then the function goes up to the right hand side like this. Okay, so that's why we called it as a turning point, and we have here the least value of the function at this point. So the function has here a minimum value. Okay, so the minimum value of this function would be 0, since the function goes down until reaches 0 and 0 and then goes up. So what about the increasing and decreasing intervals? So as you can see here, the graph goes down, down, down until we reach 0, and then starts goes up like this. So the increasing interval, firstly, it's from this point, which is 0 and 0, and goes up here. So, and we mentioned that this graph is extending to infinity. So we don't have the end of this graph. So we are from 0 to infinity is the increasing interval. So it's from 0 to infinity. On the other hand, the decreasing interval would be from negative infinity to 0, since the graph goes down in this interval. So any number belong to this interval or to the negative section, or anything less than 0 would be in the decreasing interval, and anything belongs to the interval which is higher than 0 and goes up, so it's going to be the increasing interval. So these are the key features of the parent quadratic function when a is higher than 0. So what would happen if a is less than 0, or a negative number? So let's see together what would happen in this case. As you can see here right now, that we still have the same graph, but this graph is upside down. So when a is less than 0, or a negative number, what would happen in this case? What are the things that are changed in the features of the function? So let's talk about the domain first. If we use the idea of moving in the x-axis, we are going to use this guys moving from the left hand side to the right hand side. So this guy still can see the graph below him, but instead of above him like the previous one or the previous case, it's gonna be below him. We don't care about this, but since the person can see the graph anywhere, so we're still talking about all real numbers could be used in this case, which is the domain. The range of this function would be by using the idea of moving the y-axis. So if this guy here is moving from from the bottom down here to the top, so he can see the graph to the right and to the left, to the right, to the left, until we reach the point 0 and 0. So everything below 0 and 0 would be belong to our range, and anything higher than 0, there is no graph here. So I'm going to say that y would be equal, less than, or equal to 0. The line of symmetry, we're still talking about the y-axis, since the graph is already symmetric across y-axis. So we have here y-axis as a line of symmetry, or x is equal to 0. And I prefer to use x is equal to 0, since we are talking about the line of symmetry, because later we're going to talk about the equation of the line of symmetry. So the vertex, we're still talking about the same vertex, which is the origin point on 0 and 0, but in this case, instead of having the minimum value, we have the maximum value. Why? Because the graph goes up here in this section, in the green part, goes up, goes up, goes up until we reach 0 and 0. So this is our highest point, or the maximum point. So the maximum point in this case would be 0, and from this point we are going to go down again. Okay, the graph goes down again, or decreasing again. So what about the increasing interval? The increasing interval would be from the negative infinity to 0. So negative infinity to 0, any number less than 0 would be belong to the increasing interval, and the decreasing part would be the one to the right, or the part to the right. So this part would be from 0 to infinity, and these are the features in case we have a negative number or less than 0.